any homework questions from last night, please make sure you get your homework down. I'm going to drag this up to the top screen and unfreeze that. So 3-2-3 was yesterday, and I told you guys to try the homework and you didn't have to get done with it. We're going to pick up in the lesson, but if anybody had homework questions, I'd love to field those. Especially like 59, 60, even 61. 61 gets a bit more challenging. Do we need more time to get through the assignment? So let's just be honest here. Who just didn't get to this assignment? It was trick or treat, all that. Okay. So not surprised. It's okay. All I did last night was hand out candy too. I was a penguin with a fog machine. It's all good.
Wait, what candy?
All the best.
Oh.
Milky Way, Snickers.
Oh.
No, I'm a teacher. You realize how much money we don't have? All right, so since most of us did not get to the homework, we will just come back. We're going to be diving in to 353. So once you get your planning book filled out and you get your book out, we're going to be...
That's what I forgot.
True what?
I don't have a planning book now.
That's what you forgot? Who thinks they got the best haul last night?
Probably not.
Haul, like what you took, what you like gathered.
I
Your
got
haul,
an experience.
You got an experience. There you go. You got an experience.
No,
I had a kid.
I
I think it was, so there were these two boys, probably about your guys' age, and they were all about like trick or treat, trick or treat. And I'm like, what if I say trick? And the dude's like, I got a cool trick, and he did this like yoga pose, and I told him it was yoga, and he like got upset. He's like, that's not yoga. Yeah, I've done that at yoga, dude. All right, we gotta dive in now. So if we look at 353, we just want to remember what we were talking about yesterday. Now we actually already talked about this, so I need you guys at your group to process through what was our quicker way for solving -10 minus -2 minus -2 minus -2. Sorry, my zoom is making that look a little weird. Actually, I'm going to zoom further and see if that helps. Yeah, there we go. Yeah. This. Talk at your group. What was our easier way? If you can't remember, check your notes. You should have it written down. We'll give you about 90 seconds to refresh your memory from yesterday. Make sure everybody knows which one you talk. You just say, hey, it's this, right? You're essentially confirming with each other. You have notes from yesterday? Cool kid? Nice. We're gonna go to the cards. No, it's random. How can you be upset about random?
That's the point, because you don't know if you're going to get paid.
Annika!
Oh, great.
Annika's the one upset about the cards. Annika, what's our easier way to do this?
-10 minus -2 times 3.
Yeah, now, I totally agree with you, but I'm going to write it in a tiny different order. -10 minus... Well, actually, I'll write it the way you said it first. Minus -2. Yeah, my brain's ahead of itself. Minus -2 times 3. Now, why did you say that? Why did you do it like that? There are 3 -2's that get subtracted away. Now, when I think about this, I would actually probably write this -10 minus 3 sets of -2. These are the same thing because multiplication can change places. What's that called? Starts with a C?
Commutative.
Commutative. Thank you guys. We're starting to learn that one. So whether I do it this way or that way doesn't make a difference. What do I get when I do minus a negative or the opposite of a negative or the opposite of subtraction? Patrick? Addition of a positive, because the opposite of negative, positive. Things get bigger. So actually, I end up with negative 10 plus 6, and we ended up at an answer of negative 4. Thank you. Like I said yesterday, we did this lesson in a very different order than what they do. I looked at it and evaluated that I thought we could probably do it a little bit differently. So jumping on to 54, we're going to finish the rest of this lesson pretty quickly. So talk as a team about how you can evaluate this product, and more so, how you could say it. Even if you can find the answer, I want to know how you could say what we're doing to get the answer. We'll give you like at least 2 minutes. 54. Yep, 54. Whatever's going on in language arts is super creepy, weird.
Oh yeah, it sounds like a fan.
I like it's fun.
About 30 seconds, we'll call on somebody randomly to see if you can explain this.
Ding.
You guys won the candy corn stuff yesterday, right?
The
Happy
taffy was
yesterday?
so good. Yeah, they didn't win it.
We'll make being able to explain this. Not just the answer. No, we're using cards. So, I shuffled up yesterday. Liam, somebody from your group or yourself, can you explain how to think about this? So, hold up. First off, do you have the correct answer? We should check. So, what do you think the answer to this is?
-77.
I'm going to move on to the next group. Mr. Hopkins.
Oh.
What did your group think the answer to this was? This is one of those times when it probably would have been good to be on task, right? Did we talk about this as a group, or did we kind of just chill?
We talked about it.
Okay, what do you guys think?
We did. I thought we were thinking the same thing as Liam. Like it could be negative.
Allie's looking at me like she kind of disagrees. Okay, so you're thinking the same thing as Liam. What are you thinking, Allie? Okay. Oh, I totally know how you got that. Be careful. When we have a number right up against parentheses, you might want to make a note in your notes, that this is multiplication. Now, it doesn't explicitly show it. It doesn't have the dot. But what we're doing here is a negative value times a negative value. Nathan, what did your guys' group think this was? How? Can you explain it?
Because, well, if you multiply two positives together, you get two positives. You multiply negative and a positive, you get negative. But if you multiply two of the same, like negatives,
Okay.
then you get positive.
So that's like a rule. Can you explain how you would talk to somebody about, like, how would you explain this situation? To make them understand it's got to be a positive. So we had two different groups tell us that it was going to be negative, and that was incorrect. How can we get them to understand that it should be positive?
You multiply a negative by a positive.
But that's like just a rule. Can you like talk in like a situational, like when we set up problems that are like word problems? So what if the first number wasn't negative? Think about what if it was this? How would we talk about that? How do we talk about multiplication? What words do we use? Alex?
Add 11 7 times.
Not add 11. Think about if we were making this with integer tiles. How would you show this with integer tiles? Was that a hand or an I don't know?
I don't know.
Liam?
You can get 11 negatives, and then,
Write this on your paper without the negative in front. Write this on your paper. Was that a hand or you just brushed it?
Yeah.
Yes?
Yeah.
So how would we explain this?
7 groups of 11.
Thank you. 7 groups or 7 sets. And I'm going to use sets because it's a shorter word and I'm kind of lazy. 7 sets of 11 negatives. Thank you very much, Allie. 7 sets of 11 negatives. Well, if I have 7 sets of 11, what do I have? 77. And if they're all negative, we end up with negative 77. But that's not what we actually have. What we actually have in this problem puts an extra negative in front. So I'm going to swap places on my screen really quick so I have more space to write. Sorry, guys, bear with me. So then write our negative 7 times negative 11. And we are going to explain this what else can we call a negative symbol? Or what else can it mean? Instead of saying like, I mean this would sound awkward, what if somebody said it's the negative of 5? What word should actually go in there, not negative? Say it louder.
opposite?
The opposite. Please write this out. It will help you get to Allie's answer. The opposite, if you spell it right, which I'm struggling with. The opposite of 7 groups of negative 11. And if we know that 7 sets of negative 11 would be negative, what's the opposite of a negative? A positive. That's why a negative times a negative has to get us, I hate green, so really, Allie and this group, see math class. Well, I can give it to you now, so you don't necessarily take it to the class. By the way, when I give away candy, and I have my go-to candy is Dum Dums, which I now have like 1,000 of, because when I'm giving away candy, it's normally because you're not a Dum Dum. Yes, so it's an ironic candy. And suckers are easy because they're on a stick, and if you don't want to like eat it all at the same time, it's Smarties, yeah, it works too, but people complain that they're chalky, so. All right. Also, now I never want to show this until we talk through it. These rules are right up here. So our addition and subtraction rules are a little bit blocked by the camera. You kind of have to move around a bit. But multiply and divide, same sign. When we're only talking about 2 numbers, same side yields a positive answer. Different signs yield a negative answer. Now the second step down, especially in the pink, you don't really have to worry about that yet. That deals with inequalities. We'll get there. But all you need to remember is that when working with 2 values, the opposite of a negative, 2 negatives, make a positive. Now that's only with multiplication. Don't fall into the trap of thinking that works with addition or subtraction. And we're going to skip the make a poster part because we are a little short on time for today. So really quickly with your team, evaluate these products. And then we're going to run through them all together. I'm just going to draw random cards. So we'll give you like 2-ish minutes. The numbers themselves are not that difficult. So please write the problem and then the answer in your notes so that you have the original numbers written out and the answer. So I'm going to list them all. Then verify with your team that you guys all agree on the answer and why. You hear like maybe 2 groups talking. You can be talking while you're solving.
So we just find the answer.
The biggest thing is whether it's negative or positive. That's the biggest thing that you are concerned with. We're going to write my answers in deep red.
You should do the mid-color.
The what?
The mid-color.
It just, you can't see it very well. It's too loud.
I like to make.
Red?
Eleanor, do you know what the first answer will be? -12. Allie, you just gave me the last one. Renaud, do you know what -4 times -3 will be? +12, because we have those 2 negatives. Patrick, what about -4 times 3? Negative or positive?
12.
12?
Oh, well, no, negative.
How many negatives are in the setup?
1.
1, which means my answer will be negative. We have 3 groups of -4, or the opposite of 4 groups of 3. -12. Be careful. Questions on the first 3? Delaney. What about the next one?
-14.
-14 is absolutely correct. Emma, our next one, where's Emma? Nice flannel. 14 positive, because we have 2 negatives. The opposite of a negative cancels out. And Matt, what's our last one here?
-14.
Yeah, -14. When you only have 1 negative, the opposite of 2 sets of 7, or think of 7 groups of -2, or however you want to think. Now look at Marcy's problem. So Marcy's asking Daria. Now you had a problem like this on your homework actually. So if you haven't tried your homework, this will help you immensely. Think about what Marcy has and see what you think. It says Daria helped her by writing the steps, copy, complete, and give a reason for each of Daria's steps. So copy this down, and then we're going to talk about why. And we have to fill in this little blank. So go ahead and copy this process in your notes. I'll give you a minute or 2 to get that down and talk with your team if you want. Do we all agree that -1 times 0 is 0? Yeah. Anything times 0. 0 times anything. If you have 0 of something, it's 0. So we agree with his start. So as we go through the process, check. Do we agree with what he did? Marvin, can you explain what he did between step 1 and step 2? Like, what's the change? What did he do? He changed something. The -1 stays, the 0 stays. It looks like this is the change. Do you know what he did, or do you want to ask somebody from the group or pass it off?
Nothing.
What do you mean?
He made nothing.
I love it. What, so how? What do you? I get what you're.
A positive plus a negative, just nothing.
Yeah. So he showed that the nothing can come from a 0 pair, right? If we use that keyword there, he showed the 0 pair is really what he did. He formalized this 0 can come from a 0 pair. Do we all get that? So then, Emily, do you know what he does? And this one's hard. I should look before I say, but this is the thing with using cards. It's just random. Francesca, can you tell what happens from step 2 to step 3? Is Emily sick or like traveling? Emily, feel better. We want you back. Nobody watches the videos, but if she does. Do you know what they did, Francesca? This one's harder.
There's another -1.
Yeah, how did that happen?
And -1.
You can't just throw it in there. We'll make this one worth candy. Anybody know what just happened there? Ooh, hand went up, then hand went down. Do you know?
Oh, because additive, I'm thinking additive inverse, but in the top it says negative, she says -1 times -1 equals 1. So I'm thinking if that is it, if that's the case, then add the -1 to that. Oh, wait.
But what? So between steps 2 and 3, how did I get to step 3 is what I'm asking. Do you know? You can't just add things in. Monica?
What was -1 plus 1? It was -1 times -1 plus 1.
Ooh, so this was multiplication in between here.
And that gets you a positive.
Do we have this written in our notes? Just making sure. Out to the side between steps 2 and 3. We're going to write a really important word that starts with a D. When we have multiplication of 2 different things, right? These are 2 different numbers. We break it apart, and that is called distribution. Please write this in your notes. We just performed a distribution of the multiplication. That's also called the distributive property. So we distributed that multiplication. Draw these arrows in your problem. The arrows both come from -1. They go to each of the other values. The first bottom, like lower arrow, gives us this, the -1 times -1. The second arrow gave us -1 times +1. Here, I'll even color code that. So the first arrow I'm going to leave green. The second arrow I'll make red. And this was that red part. There are colored pencils at your desks if you think color coding would be helpful. Then, so we should stop. Does this make sense? If it's at all confusing to you, it's like a situation where if we had, let's say, 7 times z plus 4, right? We don't know what z is, but I know what 7 is and I know what 4 is. If I have 7 sets of something and 4, I'd do 7 times the z, 7 times the 4, I'd get 7z plus 7 times 4, 28. Now, the weird thing that most people like get confused on with this step is why, right? These numbers could be combined. We're working this process backwards. We're trying to explain to Marcy why this works. So essentially there's no reason to do what we just did because these are both numbers. Later, when we work with variables, it's very, very important. So then what's the opposite of 1 times the opposite of 1? Well, what's the opposite of an opposite, or the opposite of a negative, or the negative of a negative, or what do we get? Positive, right? Because the opposite of a negative. So this becomes positive 1 plus negative 1. Is this true? Is that last step true?
Yeah.
Yeah. And we see here, this is actually what in math we call a proof. Anybody have any older siblings, like in high school math or anything? They will probably get to a point where they're writing proofs, where mathematically you have to show why something is true. We just showed why -1 times 0 is 0. And we can actually show this with any number here. Making the 0 pair, it'll always make additive inverses. Questions there? So we may not get as far as I planned today. We got like 15 minutes left. But moving on to 357. Try these out with your team. The same techniques, same rules or policies or whatever you want to say, apply for division. So if we are dividing, it's the same rules as multiplication. So if we do this first one as a whole group, let's quit moving. -18 divided by 9. If I have negative tiles, 18 of them to be specific, and I divide them into 9 groups, right? I have 18 negative tiles, I make 9 groups. What will be in each of the groups? Nathan? Yeah, there will be 2 negatives in each of the groups. Because I start with 1 negative and make 9 groups, there's got to be 2 negatives in each group. Well, by 1 negative, I mean 1 negative value. So try those next 3 on your own as a team. On your own as a team. And then we'll come back together in a couple minutes. Then that's the end of 3.2 section. Yeah, so this starts. Those real reaction. This is. That was a fun, like, I could not explain that to Tom and Brian a year-ish ago. I was over there. What does it mean to divide a mixed number by a fraction? We had this really prolific conversation about it, like how to model it. Really weird. But it makes, hopefully it makes sense. Like, but I don't want to rush to get there. We should not try to get there this week. Right. I've lost my stat. You've never watched, what is it, Princess Bride? Where they're like, I love the theatrical, like. I also love their scene where they have the sword fight and they're being like very, very polite with each other.
Yeah.
What you don't know is I've been fighting you left-handed this whole time. What you don't know is Alright, sorry, good movie. Aubrey, when we look at 45 divided by -3, can you tell me what we're going to get there? Negative 15. Now, how do you know that? Yeah, 3 times 15 would be 45. And what do we have in our division problem? 1 positive and 1 negative. So we will get a negative answer. Any confusion on this? B is negative 32 divided by negative 8. By the way, somebody asked in a previous year, previous class or something, they said, wait, I thought parentheses always meant multiplication. How are we dividing? Parentheses can also just say, hey, this guy's negative. We're keeping this negative in here. So these parentheses are just because the 8's negative. Kate, what do we get here?
4.
Positive 4? How did you get that?
Well, like 2 negatives equals positive.
When multiplying or dividing?
When divided. So then 8 goes into this.
So just make sure this is clear. The same rules apply, multiplication and division. When I say or, it's saying we use them with either, not you have to choose. So those rules apply. When we think about this, you can think of 32 negative tiles broken up into groups of negative 8. Make 4 groups, and those groups would be positively countable. Zoe, what about C? Negative 54 divided by 6. What'd you say, sorry? Negative 9. How do you know that?
54 divided by 6 would be 9, and there's 1 negative.
Yeah, we start with 1 negative involved, my answer is going to be negative. Essentially, one thing you can kind of put in your head to remember, pairs of negatives, if there's pairs, become positive. Pairs become positive. Every time a negative can pair with a negative, Patrick's looking at me weird. Every time you can pair with a negative, negative paired with a negative will make positive. Pair positive. In my head, that works. If it doesn't in yours, that's fine, but that works in mine. Because I don't really do anything special for lots of those, like Halloween and whatever else. One thing I will do for you, since I know that most of us were trick-or-treating last night, if you would like to write a little learning log to help you understand what we just did to formalize those rules, that pairs of negatives make positives, that if there's 1, they stay negative. If you would like to formalize that in your math journal, I'm going to give you time to do that right now. And or use the rest of this class time to work on this homework assignment. So you can talk with your team to talk over these problems. If somebody's already done a couple of them, you can discuss those. But you got the next 8 or 9 minutes to just work on homework, get stuff done, or write that formally write stuff to help you remember. But if you start solving some of these problems, that'll help you remember to also. First problem in the homework deals with addition and subtraction. The next problem deals with multiplication and division. So if you want to, and guys, by the way, give me your ears for a second. I don't need your eyes, but I need your ears. Your homework can be out of order. If you work on a problem with a friend, don't feel like you need to leave a gap of paper. Just put that problem first. If you want to start on 360, because we just did multiplication division in class right now, start on 360, then do 359 after that. I don't care. I just care that all the problems are there. Make sense?
Yeah.
Cool.